We are going to evaluate the flux of this vector field F through this surface S, and the equation of S is given by this equation. The position vector is a function of these two parameters, and the parameters are restricted by these values. So let's go on the calculation step by step of this surface integral. So here we have a few vectors of the vector field, but now let's just localize ourselves to an elementary element. So here we have an arbitrary point on the surface, and this blue vector is the vector n, the normal vector, and this light blue vector is a vector from the vector field. Okay, and so let's consider a tiny element around this point. Okay, so here we have a tiny area element on this surface, which we had seen as equal to this quantity for delta u and delta v very small, and this is the unit normal vector obtained by using this position vector r. That is, it is the cross product of partial derivative with respect to u with that with respect to v divided by the magnitude, and we have assumed that this cross product is not zero anywhere on the surface, and this is the value of f, the vector field at this point, and we are assuming that this area element is so tiny that we can assume the values to be the same throughout. And then when we go ahead and take the dot product of f with n and multiply with this ds, then after taking the limit or the Riemann sum, our integral will turn into, so what we have is that we just transform this to these values, that is f dot this unit vector, and then the ds we take as this, and where d is the parameter domain given by this, and after the cancellation of these quantities, all we have to do now is just to compute this integral. So let us quickly do that. So now we are going to compute this integral where f and r and the limits of u and v are given by as stated here. So what we have is that we have integral from 0 to 1, and that's for u, right? And then from 0 to pi, that's going to be for v. Okay, and I'm just writing them slow, okay, so that hopefully you understand it better. So z is v, y is u sine v as we move along the surface, because we are going to take the values of f along the surface, and x is u cosine v. Okay, and then we have dot product with, or dot product of this vector with, let me just use a different bracket for a moment. So what will be dr du? That will simply be, so the derivative of u cosine v with respect to u is cosine v, that of u sine v is sine v, and that of v is 0. Then we go for cross product here. Okay, and what will we get is this. When we differentiate this with respect to v, what we get, negative u sine v, right? Sine v And then we have u cosine v for the second component, differentiating with respect to v, and then we get a what? 1, right? And then our next part will be, let me just assume that this equal sign is assumed here, okay? And then we are going to have 0 to pi are the limits of dv, and then du, right? Okay, so this is what we are going to work with. All right, so let's compute this part. Okay, so that is this is going to be the determinant of the, so we just write it in the determinant form just for computational convenience. Okay, so we have ijk cosine v and then sine v, then we have a 0, okay, and then negative u sine v, u cosine v, and then a 1 at the end. All right, and what this will become is, this is going to become, we have sine v minus 0 when we are looking at this portion as a cofactor. So we simply get sine v. All right, then when we go for j, ignore these rows and column. So this part is 0, so we simply get what? Negative cosine v, right? And then at the end we will have u cosine square v, then negative would be positive, u sine square v, and the two together would be u because of the Pythagorean identity. I hope you didn't mind me not writing that part down. And so when we compute this dot product, okay, so here we go, we are looking at this dot product here, and so this dot product is going to be v sine v, okay, minus u cosine v sine u cosine v, or rather it's okay, I mean it could have been the same, but let me just write it the way it was. So u sine v cosine v, and then we get u square cosine, so u square cosine v. Let me just take it into the second line because it's not going to fit here. So yes, so what we get here at the end is u square cosine v, right? And now we are ready to integrate here. Okay, so what we shall do is this, we'll just take the limit, okay, or the integral with the limits, okay, and then what we get next is, next we get the dot product of these two, which we just computed right here. Let me put that in a bracket. So we got this, and then we have dv du, right? Okay, so first we shall do integration with respect to v, and then we will go with respect to u afterwards. So what we get is that we have this, and then when you are integrating u sine v with respect to v, then you will of course do the integration by parts, okay, and when you do integration by parts, then v sine v, that would be what? Negative v cosine v, right? And then negative, and then negative again, that will make it positive, and then that will be antiderivative of cosine v, that will be what? Sine v. And then here we can take sine v as another variable, say w, so cosine v dv would be dw. So the antiderivative of sine v cosine v would be what? That will be simply sine square v over 2, right? So we got sine square v over 2 here, and antiderivative of cosine v is simply sine v. I don't know why am I retaining this here still. Okay, so then here we got this, and then this we will evaluate from 0 to 1. So let's do that. Okay, let me get the symbols down here. Okay, so we got this. The upper limit is pi, the lower is what? 0. Okay, so what we have then is that if we apply pi here, then what shall we get? Let's see. So here we will get negative pi cosine pi, which will be positive pi. So let's just write it as positive pi. Sine of pi will be 0, and then here also sine of pi will be 0. So that is out. Sine of pi is 0. So this is out, right? So what happens is that at pi, this whole value is simply pi. All right, and when v is 0, this is 0. Sine of v is 0 anyways. So the whole thing just becomes equal to what? Pi. And then this, of course, is going to finally become what? Simply pi. All right. So the flux of F through that surface is how much? That equals to pi units. All right.